Hello. Today we shall see how the yarn structure and the properties are related with each other. So before we go into the yarn structure, let us try and understand what are the possible fiber types in any yarn structure. So the first type of fibers that one would find is the core fibers. These fibers may be straight or inclined. Core fibers constitute a major proportion of the yarn. Core fiber orientation has a big impact on the stress strain behavior of the yarn. So the second type is the wild fibers. These fiber groups randomly protrude from the main yarn body in any direction. Loops may also be observed along the yarn axis, and these groups are also classified as wild fiber groups. The wild fibers increment leads to a more hairy yarn. So we come to the next type of fibers, that is the wrapper fibers. The helix angle of wrapper fibers around the core fibers are considered similar. There might be some degree of inclination with respect to the yarn central axis. Then we have wrapper wild fibers. These fibers wrap around the core fibers in a different direction from the regular wrapping fibers. The wrapper wild fibers have a scattered appearance. There is no common angle for wrapper wild fibers because of their disordered appearance. Then there is belly band fibers. These fiber groups are the main body wrapping fibers composed of either core or wrapper fibers. Belly band fibers are observed in the upright position with respect to the yarn central axis. So having understood these five types, let us have a more understanding in terms of this image that is shown here. So the core fibers, as we can see, it is marked here. So these are all your core fibers which you can see lying straight. These fibers may be straight or inclined. Core fibers constitute a major proportion of the yarn, as we have seen. Core fiber orientation has a big impact on the stress strain behavior of the yarn. So now we come to the wild fiber type, where we see this is the wild fiber. These are some wild fibers which are protruding out of the body of the yarn. So these fiber groups randomly protrude from the body in any direction. So one may see loops also along the yarn axis. And as the number of wild fibers increases, it will lead to more hairy yarn. As you can see, these are the hairs that are protruding and are known as wild fibers. You come to the wrapper fiber type, and we see these are wrapper fibers which are shown here inclined, and they are in they're wrapping in bunches all over the surface of the yarn. So the helix angle of the wrapper fibers around the core fibers are considered similar. So the helix angle, they are all almost same. There might be some degree of inclination with respect to the yarn central axis. So there you will find some amount of inclination with the yarn axis. When we come to wrapper wild fibers, and these are this kind of fibers where they are to a certain extent embedded in the wrapper fiber, but they are still protruding out of the body of the yarn. So these fibers wrap around the core fibers in a different direction from the regular wrapping fibers. The wrapper wild fibers have a scattered appearance. You'll see they are scattered all over the place. There is no common angle for wrapper wild fibers because of their disordered appearance. So coming to the fifth type, that is the belly band fibers. You can see here these are the belly band fibers that are there. These fiber groups are the main body wrapping fibers composed of either core or wrapper fibers. Belly band fibers are observed in the upright position with respect to the yarn central axis. So this is the upright position. So with this, let us see exactly how our Airjet yarn structure looks like. Airjet yarn has a fasciated or a core sheet structure. This we already know. We also know that in the core the fibers are parallel without any twist and is surrounded and bound together by wrapping fibers. The wrapping fibers provide the compression forces in the core and the necessary friction to achieve the desired yarn strength. Plus, we have also seen earlier that around 15 to 30% of the fibers in the Airjet yarns are wrapping fibers, and therefore the core is completely covered by the wrapping fibers, giving it a look just like the ring spun yarns and are fully twisted. Now we are calling this wrapping fibers, but they are not wrapper fibers, of which we must take note. These are fibers which are wrapping the surface of the yarn are completely covering the core. But there's a difference between these fibers. We are calling them wrapping fibers, but they are not same as the wrapper fibers that we have just seen. Wrapper fibers you would find normally in a rotor spun yarn. We'll see the different structures later on. Coming to the airjet yarn strength. Airjet yarn strength is dependent on the wrapping twist. We have seen this in our earlier lecture, that wrapping twist would decide the yarn strength. The strength wrapping twist graph, that means if you were to plot a graph which shows wrapping twist against strength, it would be, of course for a airjet yarn, it would be similar to the strength twist curve of a ring spun yarn. And it would look something like this, similar to the one which we saw under ring spun yarn strength versus the twist graph. So it goes on increasing up to a certain extent and then reduces. On the x-axis you see the wrapping twist, on the y-axis you see the yarn strength. The strength of an airjet spun yarn also depends on the percentage of wrapping fibers, but to a lesser extent than wrapping twist. So the strength not only depends on the wrapping twist but also depends on the percentage wrapping fibers, which is the second factor. 15% or more the wrapping fibers would give good strength values. If the wrapping fibers were to drop below 15%, the yarn is no longer fully covered by wrapping fibers and the yarn strength is seen to be reduced. So let us compare the different yarns that we get from different systems, and let us see how they compare with each other for yarn strength. On the x-axis, we are seeing the different types of fibers that are being shown over here, that are used, and relative yarn strength, and you are seeing the different kinds of spinning systems. So on the x-axis, as we saw, it starts with cotton waste, and then the staple length is also increasing up to say 1.5 combed, which is 30 mm. And then also they have compared polyester cotton blend of 6733 as well as any other man-made fiber. So looking at the strength values, the rings spinning is the standard. It is marked at 100, and all other yarns are compared with ring spun yarns for strength. So looking at the first one, that is the compact, the yarn spun by compact spinning. Of course, we know that compact spinning gives us more even yarns because it's a modification over ring spinning, and we see the effect in the properties, that is yarn strength has improved over ring spun yarns. Coming to the next, that is the rotor. We see that it is good yarn strength in the beginning, and it will go on reducing. Next we see the let us see the friction spinning. Again, it's a similar graph. It goes on reducing. Then we see the two nozzle airjet spinning, which you see that is the only system where as you go with the fiber, the yarn strength goes on increasing. So having seen this particular graph for strength and comparing them with the different systems that this particular ring spun yarn compares with, let us go to the next graph. It tells us strength of rotor versus airjet. The strength will tell us rotor versus airjet versus ring. How do these three yarns compare for strength? So this is the graph showing that. We see that this color is shown for open end, but this is actually rotor. Then this color is for airjet, and this blue is for ring spun yarn. So when you compare yarn strengths, we see that it is done for 100% cotton carded. So strength of the airjet is somewhere in between the ring and the rotor. We see in both these whether it is yarn count of 20s or 32. We see that airjet somewhere lies between the two, rotor as well as ring. And the second thing we observe is that it is nearing ring for long staples. That means when you come to a finer count where you are required to use longer staples, you find that it is more, the strength is nearing or more closer to the ring spun strength. And when it is for a coarser count, it is more towards the rotor, which is for short staples. So having seen this, let us see another comparison. That is comparison of yarn strength, where you are using 50% polyester and 50% cotton carded. The earlier one was for 100% cotton carded. So again we see the same trend over here. Airjet is in between rotor and ring for strength. So let us have a look at what is the scenario in case of yarn evenness, thick thin places and nibs, and which we shall compare airjet with ring. The drafting unit influences the evenness values of the airjet yarns. Airjet spun yarns achieve good evenness values as compared to the ring spun yarn. In case of airjet yarn, sometimes the wrapping fibers or fiber bundles might be counted as nibs. So in the instrument that is counting nibs, the wrapping fibers or the fiber bundles sometimes are mistaken, or rather they are made to count as nibs. So that is why there are chances that we might see an increase in the nibs along with the wrapping twist levels. So since with decreasing spindle speed, suppose we have seen in the earlier lecture where we saw the factors that influence the wrapping twist levels as well as the number of wrapping fibers that are there. So one of the factors we had seen was decreasing spindle speed. So the moment we decrease the spindle speed, the yarn spends more time uh, in the vortex, and therefore there is an increase in the wrapping twist. There is therefore, since the wrapping twist is sometimes counted as nibs, we will simultaneously see increase in the 200% nip level. So when I say 200% nip level, let us understand what this actually means. It is whenever we say plus 200% nip, it indicates the cross section at the nip is 200 times of the mean cross section of the yarn, or if sometimes even more. The nip level is almost similar to the ring spun yarn if the wrapping twists are not excessively high. So you can really compare them with the ring spun yarns, and they are quite similar in terms of nips. So this is a graph showing the spinning speed as you go on increasing the spinning speed. Um, we see that the nip level that is there, it goes on reducing, because again it's a counter point to this, it's a vice versa of this. As you go on increasing the spindle speed, what will happen is it will spend less time in the vortex, and when it spends less time in the vortex, the number of wrapping twists will be less, and that's why it will show as an effect in terms of neps, because wrapping twists are counted as neps sometimes. So this is the explanation of this particular graph. So now let us look at yarn hairiness in case of airjet versus ring. In airjet yarns, the core fibers do not contribute to the hairiness of the yarn since they are embedded in the body of the yarn. The wrapping fibers, which are around 15% of the fibers, is a relatively small percentage, and hence the hairiness of the yarn spun on airjet system is lower than that spun on the ring spinning system. So this particular trend we see particularly for yarn hairs of length 3 mm or more. So when the yarns were tested, there are different types of yarns that are shown. 20s NE is compared for ring as well as airjet, and then there is a comparison between 30s ring and 30s airjet, and both combinations are taken carded as well as combed. So let us see them one by one. So when you come to yarn hairiness, what on the y-axis we see that yarn hairiness in case of combed, this is a combed one for in the ring spun type. So the hairiness is seen to slightly increase over here. So coming to the airjet, the hairiness overall, when you compare for the same count with ring spun, it is so much drastically reduced. Then we come to a finer count where we see that combing is helped here. The hairiness has reduced. That means that even in ring spun yarn, if the hairiness reduction is seen only if you go for finer counts. And same way, when we compare Airjet with ring spun yarns, we see that definitely just like before, whether it is coarse or fine, you see a drastic reduction in case of hairiness. So coming to the next point, also higher the wrapping twist, lower is the yarn hairiness. This trend we also see in ring spinning, just like ring spinning. So here there is a graph showing twist multiplier and the hairiness. So Uster hairiness as a function of wrapping twist. So we see here as you go on increasing the twist, the hairiness is reduced. So lower hairiness in the Airjet yarns have a positive effect on the abrasion resistance of the yarn, and we have found that lower the hairiness, it is better, and it is better than ring spun yarns also. So let us take a look at this video that is there. Here we are going to see 4 types of yarns, and we are going to see the image of how the fibers are distributed along the yarn length. And in the video further, there will be a close-up view of these particular yarns. We need to see how they look different from each other. So let us go ahead and watch. So here in terms of structure, we see that compacted, that is the compact spun yarns. We can see clearly that the yarn is more even when you compare it with the normal ring spun yarn. So let us go ahead. In this yarn structure, which is the rotor spun yarn, we can clearly see there are wrapper fibers here. Here also you can see they are in bundles, they are wrapping. We have seen how wrapper fibers are formed in case of rotor spinning. So this is how the yarn would look like, which has got a look very different from ring spun yarn. In case of Airjet spun yarn that we have just seen, we can only see the yarn is covered with, you can see the wrapping fibers rather. They are, the surface is completely covered by the fibers that would be used for wrapping. That is around 15 to 30% you would find that the fibers are wrapping around the surface. So this is somewhat it is colored so that you can see how the fibers twist and turn in the yarn structure. So having seen the structure in detail with the help of a video, animated video that is there, we have compared the 4 yarn structures, and with this we come to the end of this lecture. Thank you.